Hello and good day everyone. Welcome back to my YouTube channel. I'm Sir Marcy and we are still on our second part of my video lesson, which is all about quarter 3 week 5, and that is all about the laws of proportion and basic proportionality theorem. If you're new to my channel, please consider subscribing and hit the notification bell so you'll be updated with my latest videos.
In my previous video, we already discussed ratio and proportion. Remember that a ratio is a comparison of two values expressed as quotient. In short, when we talk of ratio, this is merely fractions, okay? For example, we have here a class of 12 girls and 18 boys. The ratio of girls to boys is, we have 12 all over 18. This ratio can also be expressed as an equivalent fraction. So the equivalent fraction of 12 all over 18 is 2 all over 3. Also, in my previous video, we discussed proportion. When we say proportion, it is an equation stating that two ratios are equal. So going back to our example, we have the ratio of girls to boys, that is 12 all over 18, which is equal to its equivalent fraction 2 all over 12. These two states that ratios are equal. Okay, these two are equal ratio, and that is why we call them proportion. Okay, now in my previous video also we discussed how to solve for unknown values. Okay, so I already discussed this using different fundamental laws of proportion, but for today I'm going to show to you how to solve this using the product of the means and product of the extremes law. So in example number 1, we will just apply cross product. So meaning we will multiply 6 times x, that is 6x, is equal to 9 times 10, the product is 90. After this, we will divide both sides of the equation by 6 to find the value of x. So x here is equal to 90 divided by 6, the answer or quotient is 15. Okay, so this is the answer for question number 1. Now let's proceed with question number 2. So we again apply the cross product. So we have 8 times n, the product is 8n, is equal to 10 times 10, that is 100. Then divide both sides of the equation by 8. Okay, so this is cancelled out. Then what is left is n is equal to 100 all over 8. We can simplify this as 25 all over 2, since we can divide this 2 by 4. And take note that 25 over 2, if we will write it in decimal, that is equal to 12.5. So the value of n here is 25 all over 2, or that is simply 12.5. And for the last example, we will still apply the cross product. Okay, product of the means times product of the extremes. So here we have 8 multiplied to m minus 8 is equal to 4 times 2, which is 8. Next, if you notice, we can divide both sides of the equation by 8. So this is cancelled out. We now have m minus 8 is equal to 1. Then, we apply addition property of equality. We add both sides of the equation by positive 8. So this is cancelled out. M is equal to 1 plus 8. The answer is 9. So the value of M here is equal to 9. Okay, so this is our lesson, or in my previous lesson. For today's video, we're going to continue the discussion and we're going to tackle about the basic proportionality theorem. Okay, let's start. Okay, the basic proportionality theorem states that if a line is drawn parallel to one side of a triangle to intersect the other 2 points, the other 2 sides are divided in the same ratio. And it was discovered by Thales, so also known as the Thales theorem. Okay, to sum up, based on the given theorem, the following proportions can be derived. So for number 1, we have upper left all over whole left is equal to base 1 all over base 2. So if we're going to write it in proportion, upper left is segment AX. So this one. So upper left is segment AX all over whole left. When we say whole left, we have the segment AB. Okay? So this is segment AB. So AX all over AB is equal to base 1, which is this one. So segment XY all over base 2, which is segment BC. That is why in our number 1 proportion, upper left all over whole left is equal to base 1 all over base 2. That is AX all over AB is equal to XY all over BC. Next, for number 2, we have upper left all over whole left, which is this one again. AX all over AB is equal to upper right all over whole right, which is AX all over AC. That is why we have this proportion. Next, number 3, we have upper right all over whole right. Upper right, which is this one, all over whole right. So we have AC all over base 1, which is XY, all over base 2, which is BC. Okay, so this is the proportion. And for the last one, we have upper left all over lower left. So we have AX all over XB or BX is equal to upper right, which is AY all over lower right, which is YC. That is why we have this proportion. Okay, so that is some of the some of the proportion that can be derived using the basic proportionality theorem. And to further understand this theorem, let's have some more examples. Okay, so let's try to answer this problem using the basic proportionality theorem. The given is a triangle DEF wherein segment GH, which is this one, is parallel to segment DF. Also take note that EG measures 6, this one, and EH measures 18, FH is 12. So we're going to solve for DG or segment DG. So we represent it as X. Now using the basic proportionality theorem, we can use first yung upper left all over lower left. So we have EG all over GD is equal to upper right all over lower right, which is EH all over HF. So by substitution, EG measures 6, GD is X, is equal to EH, which is 18 all over 12. Then we apply the product of the means times product of the extreme law. So we apply cross product in short. So we multiply 18 times X, that is equal to 18. X is equal to 6 times 12, that is 72. Okay? After that, we will divide both sides of the equation by 18. So divide both sides of the equation by 18. So this is cancelled out. What is left here is X is equal to 72 divided by 18. The answer is 4. Okay? So this is one way of solving this problem. I'm going to show you alternative solutions. So I'll write here solution number 1. For solution number 2, you can also apply this method. We have upper left, which is EG, all over whole left. So this one, we have ED is equal to upper right, which is EH, all over whole right, which is EF. So let's now solve. For EG, that is 6. And for ED, that's the whole left. So we have to add 6 plus X. We have X plus 6 is equal to EH, which is 18, all over whole left or whole right, which is 12 plus 18, and that is 30. Okay? Then we apply cross product. Actually, we can simplify 18 all over 30. Okay, so what is the lowest term of 18 all over 30? That is equal to 3 all over 5. Okay, then we now apply cross product. We have here 3 times X plus 6 is equal to 6 multiplied to 5. Okay, Then we distribute. So this is 3 times x. We have 3x plus 18 is equal to, this is 30. Then we subtract both sides of the equation by 18. So this is now 3x is equal to, that is 12 all over 3. Then we have the same answer. X is equal to 4. Okay, in solving for this, there are many ways on how you can find segment PG. So you just find a perfect proportion that is suited in this given. Okay, so that's example number 1. Okay, let's have problem number 2. Given triangle ABC where DE is parallel to BC. Okay, so this one, DE is parallel to BC. Then also we have AB, which is the whole left. The measure is 12. Then we have AE, which is X, and then AD, which is 4, this one, and EC is 10. So you can actually get the measure of BD here. So if the measure of segment AB is 12 and AD is 4, so what is the measure of BD? The answer is 8, because 12 minus 4, that is 8. Then from here, we can now create a proportion. That is upper left, AD, all over lower left, we have DB, is equal to upper right, AE, all over EC, lower right. Then apply substitution. AD is 4, all over BD is 8, is equal to AE, which is X, all over EC, which is 10. Okay? Then we cross product. That is 8x is equal to 40. Okay, so this one. Then divide both sides of the equation by 8. Our value for x here is equal to 5. Okay, so the value of x here is equal to 5. Okay, so that ends our lesson for today. I hope you learned something new. Okay, goodbye.